That's because if you combine many particles, then things get very complicated very quickly. You get new emergent behavior, as it's often called. You don't even need to look at difficult things like human beings to see that. If you do as much as combine atoms to big chunks called metals, you get new behavior, like the ability to conduct electricity, or being very shiny, or being very painful if they fall on your foot. Emergent properties don't exist on the level of constituents. They arise from the properties and interactions of the constituents. A single electron doesn't have a conductivity. That just doesn't make sense. Conductivity is a property that only makes sense for large collections of electrons. It doesn't make sense to talk about the conductivity of an electron for the same reason it doesn't make sense to ask whether a single oxygen atom is a gas, or what's the marital status of your small intestine. It's what philosophers call a category error. It'd be trying to assign a property to a class to which it doesn't belong. Emergent properties don't make sense on the underlying levels. But that doesn't mean they don't exist. Chairs exist, all right, but they exist on the macroscopic level and not on the level of elementary particles. Curiously enough, our universe is organized so that the details of what happens at short distances become less important at large distances. This is why, if you want to understand planetary motion, you don't need to know the population of New York City. This is why, if you want to understand chemical reactions, you don't need to know the standard model of particle physics. And this is why, if you want to become a YouTuber, you don't need to know anything. Physicists call it the decoupling of scales, the mysterious but empirically well-confirmed fact that the details of what goes on at small scales can be disregarded if you're only interested in what happens on large scales. And this is why we have so many disciplines of science, because each discipline of science has its own language about emergent properties that are adequate to its subject. But that we get new emergent properties from the interactions of the constituents doesn't mean the equations that determine the behavior of the constituents do no longer apply. Emergent behavior is a consequence of combining large numbers of particles with complicated interactions. It follows from the underlying laws. It doesn't make them go away. Some philosophers have speculated that large systems could have emergent behaviors which don't follow from the laws of the constituents. This is sometimes called strong emergence, but there's no evidence this happens in the real world.
Let me first clarify what Sabine is saying. She is saying that physics explains subjective mental phenomena. That subjective mental phenomena are not fundamental, but rather logically derived from configurations of fundamental particles, space, and physical forces. She compares it to other emergent phenomena, such as conductivity and shininess. Here is the problem. Fundamental particles, space, and physical forces are physical. That is, they have a position in time and space, and their effects are constrained to affecting the position of other physical objects. It is very easy to explain how conductivity, physical electrons moving through a physical object, or shininess, how much a physical object radiates or reflects physical light, but it is quite another thing to explain how it produces a non-physical phenomena of my subjective experience of pain or joy. To be clear, it is not difficult to explain why it causes the physical correlates of my thoughts and emotions, things like my physical responses, neural network activations, or actions. What is difficult to explain is why they should translate into consciousness and subjective experience. How can you possibly say that this configuration of matter should have a subjective experience of happiness because of its physical configuration, while another should have a subjective experience of fear because of its physical configuration, without invoking some objective definition of how different configurations should be subjectively experienced? The go-to explanation is computationalism, the notion that computation is somehow responsible. This is impossible on account of computation itself being a subjective mental phenomenon and not an objective physical phenomenon, as most people suppose. Computation is symbol manipulations. Symbols are not objective. Symbols are a subjective interpretation of objective physical states and phenomena where we assign meaning to these states. It is a subjective imposition of a system of meaning onto the physical world. Because the world is logical, we can then apply physical operations, members of an instruction set, to them, which will alter the meaning of our subjectively defined system. Me counting on my hands is computation. Does anybody think that me holding up my hand like this objectively means the number 5? Since the subject is the source of this phenomenon, it cannot be the effect of it, because that is circular reasoning. I like Sabine Hossenfelder and her videos, but she is wrong about this. If you want a more realistic theory that explains subjective mental phenomena, then check out this video.